Hello everyone, welcome to Statisticians Hub. Today we are going to demonstrate how to do multiple linear regression in SPSS. First, we start with the definition of multiple linear regression. It is a statistical method used for explaining the relationship between multiple independent variables and a single dependent variable. The multiple linear regression is used in different fields such as economics, business, finance, and social sciences. The model of multiple linear regression is given as y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus up to beta n xn plus e, where y is the dependent variable and e is the error term. Beta naught is the intercept and x1, x2 up to xn are the independent variables and beta 1, beta 2 up to beta n are the coefficients of the independent variables. Here we have taken a demo dataset for performing multiple linear regression in SPSS. Here we have taken our dependent variable as dose lib, that is dose that reached the liver of a rat, and the independent variables are weight of the rat, liver weight of the rat, dose that fed to the rat, whether the rat is pregnant or not, if yes then 1, if not then 0, and the age of the rat in months. After performing multiple linear regression in SPSS, we get three tables. The first one is model summary table, second one is ANOVA table, and the third one is coefficients table. In model summary table, we check the R-square value. If R-square value tells us how much the independent variables are explaining the dependent variable. In ANOVA table, we check the overall significance of the regression model. If p-value is less than 0.05, then we conclude that the overall regression model is significant. Next, in coefficients table, we check each of the independent variables' significance. Again, here also, if p-value is less than 0.05, then we conclude that the independent variables are significant. And from this coefficients table, we also write the regression equation. Now we open our SPSS window for performing multiple linear regression. For this, we first click on Analyze. From Analyze, we select Regression. In Regression, we select Linear. Now we move the dependent variable dose lib to the dependent variables list and select all other independent variables and move them to the independent variables list. Now we click on Statistics and check the Estimates and Model Fit box and then click Continue and finally click OK to get the multiple linear regression results in SPSS. Here the SPSS is going to provide us three tables. The first one is model summary table, the second one is ANOVA table, and the third one is coefficients table. Now we again come back to the PowerPoint presentation where we move the results of SPSS. In first table, that is model summary table, the value of R-square is 0.635, which implies that the independent variables are explaining 63.5% variation of the dependent variable. The next table is ANOVA table, which tells us the overall significance of the regression model. Here the p-value is 0.002, which is less than 0.05, which tells us that the overall regression model is significant. The third table is coefficients table, where the independent variables are listed and corresponding to each independent variable, the significance value, that is p value, is given. If we look at the first independent variable, which is weight of the rat, the p value for the same is 0.366, which is greater than 0.05, which tells us that weight of the rat is insignificant for this problem. Next, the liver weight of the rat in grams, p value is 0.035, which is less than 0.05. Thus, liver weight of the rat is significant. Similarly, the rat is pregnant or not, p value is less than 0.05. So, the rat is pregnant or not is significantly impacting the dependent variable. Now, under the unstandardized coefficients table, we get the coefficients of the independent variables and their standard error. Here, the coefficients of the independent variables for the weight is minus 0.05. For liver weight, it's 0.021, and it goes on. So finally, we can tell us that the final model for this exercise is dose leap is equal to 0.360, which is the value of the intercept, minus 0.005 into weight of the rat, plus 0.021 into liver weight, plus 0.739 into dose fed, plus 0.094 into the rat is pregnant or not, and 0.000 into age. Thank you for listening to me. Kindly like and share my video, and also subscribe to Statisticians Hub.